Welcome to this interview with Jakob Valdemar on his master thesis, which we have right here. It's a pretty thick book, so to speak. Jakob just recently finished his master's in computer engineering from Aarhus University, and you are a great example of a student coming in as an intern, working here as a student worker, and then after studies, continue on working at Lunar, and you're now working in Squad Odyssey as a platform engineer. And for those who are not aware of what Odyssey does, it's around Kubernetes clusters, it's our infrastructure, so to speak, and it's our observability platform and much more. So can you maybe provide an additional introduction besides what I just mentioned?
I think you got it covered pretty much. People often joke that I am both the guy with the most and least seniority in Power, and that's because I have been with Lunar for almost 4 years now, so a lot of seniority there. But I just graduated January this year and started full-time last month, so that says a little.
So a few months off before starting.
Yep.
Sounds like a good idea. In this master thesis, Carbon Efficient Carpenter, Optimizing Kubernetes Cluster Autoscaling for Carbon Efficiency, you write that data centers around the world are responsible for 0.6% of the global greenhouse gas emissions. And your goal of this master thesis is try to figure out a way to optimize Kubernetes and provide a better way to autoscale clusters. Can you provide some more insights into what this is, what it covers, what kind of problems are you trying to solve with this?
Yeah, so as you mentioned, 0.6% of the global greenhouse gas emissions come from data centers. So that's quite high. And what I wanted to do was basically to try to reduce that as much as possible. But taking all data centers is quite a large context and domain. So I kind of narrowed it down to focus just on cloud-based Kubernetes clusters. And so I tried to reduce the carbon impact of that in my master's thesis, and I did that by first developing a novel method for reducing the carbon emissions from Kubernetes clusters, which is called carbon efficient cluster autoscaling. And that method I later implemented as a real autoscaler.
Yeah, and you're using some open source technologies as well?
Yeah, I use Carpenter, which is a open source tool. So I developed on Carpenter this carbon efficient cluster autoscaler. Yeah.
Awesome. So in simple terms, how does your method, carbon efficient cluster autoscaling, or CESA, differ from the traditional approach of cluster autoscaling that we use here at Lunar?
Yeah, so traditional cluster autoscaling autoscales a cluster to meet the resource requirements in the cluster. So that means provisioning new nodes whenever we need more resources for example, a new service, and then deprovisioning the nodes again when we reduce the resource demand. And traditional cluster autoscalers does that while minimizing the financial costs of the cluster. In contrast to that, carbon efficient cluster autoscaling minimizes the carbon emissions from Kubernetes clusters, but still while meeting the requirements of the cluster in terms of resources.
Okay. Are there any correlation between the finance and carbon efficient footprint, or the carbon footprint that...
Sometimes there are. Sometimes you can there is a node which is just plain not needed, so you can just remove that, and then that reduces the cost and reduces the emissions from the cluster, but sometimes it is not easy to say whether or not it correlates.
And this method that you implemented here, carbon efficient autoscaling, what does it bring in terms of the carbon efficiency?
So in my thesis, I conducted a lot of different experiments on the stuff that I developed, and I tested it in various data centers across the globe in different countries. The experiments in Ireland and the United States showed an approximate of 20% reduction on average for the Kubernetes cluster. So that's quite
a
high.
lot. Yeah, that's a lot. So that's have a huge impact if all companies around the globe was using your autoscaler for autoscaling the Kubernetes clusters.
That could have a huge impact, yeah.
Nice. So how did Lunar support your research, and what was sort of the significance of the support that you received from here?
So Lunar supported my research by providing the AWS services that I used to conduct the experiments in my thesis. So basically, without the experiments, my thesis would not have been approved by my supervisor. So it wouldn't have been a thing without the support from Lunar. So it's huge, it's very huge.
So what are we doing at Lunar to reduce the carbon footprint of our software?
So first of all, we are running a cluster autoscaler which just right sizes our clusters to meet the resource demand from our service. So automatically we provision new nodes whenever we need new resources, but we also deprovision the nodes again when we don't need the resources anymore. So for example, data science jobs, we increase nodes when they are running, and then we reduce the nodes again when they are not running to make sure that we are not excessively using any resources that we don't need.
Okay, but we could be more efficient using something like this.
We could be way more efficient using something like that or doing something else, but that would of course take time. But we definitely could, if we wanted, be way more carbon efficient. Yeah.
Okay. You're also contributing to the technical advisory group, or TAG for short, within the Cloud Native Computing Foundation on environmental sustainability. Can you tell me a little bit more about that? What is your role? What is it that you are trying to do there?
Yeah, so I'm currently a co-lead for the project on creating a best practices document for Kubernetes clusters on environmentally sustainable Kubernetes clusters. And in this project, we of course define and describe the best practices for environmentally sustainable Kubernetes clusters. And this will hopefully be seen by or read by Kubernetes administrators across the globe. So it will hopefully have a huge impact, the work that we are doing there.
And does this have a place in that work as well?
It could have a place, but it will probably just be a footnote as we will be focusing on the more like accepted and consensus driven things that you can do.
But this is something that you build this on open source technology, and you have added this probably as a branch or something that you are ready to upstream, or are you planning, or is it already upstream? What is your plans for the future with this?
During my thesis, it has been very important for me to actually make sure that the work I performed could get out and live in the real world and do something. So I really wanted to get the implementation upstream as a feature in Carpenter. Unfortunately, that hasn't been possible yet, but at least it is currently open source on GitHub, so everyone can view the implementation, copy it, use it, modify it, whatever. And I hope that I can soon upstream the work.
And this is also available online?
It is available online on GitHub, on my GitHub, Valdemar.
So if you're interested in reading more, you can find everything on Jacob's GitHub. I really encourage everyone to take a look. It's really interesting project. Thank you so much for joining me on this short vlog podcast, whatever we call it. And yeah, have a great day.
Thank you.